Hello and welcome back to Ganthasastram. In the last video, we have seen what a differential equation is, its types, order and degree. Let's get into the topic, differential equations of first order and first degree. Let us now take an equation as an example, y equals to sin x. This is a normal equation. Here y is the dependent variable and x is the independent variable, because the y value changes based on the x value. Suppose if x is 0, then we get the y value as 0, because sin 0 is equal to 0. Y is depending on x, so x is the independent variable and y is the dependent variable. Now let's differentiate this equation. Y is equal to sin x, that equals to y dash equals to dy by dx equals to cos x. This is a first order differential equation. Differentiating again, we get y double dash equals to d square y by dx square equals to minus sin x. This is a second order differential equation. Here in both cases, the degree is 1. Let us thoroughly understand the topic of differential equations of first order and first degree. There are two standard forms of differential equations of first order and first degree. They are dy by dx equals to f of x comma y, m dx plus n dy equals to 0, where m and n are functions of x and y or constants. Differential equations cannot be solved in every case. They can be solved if these equations have any of the standard forms: variable separable, homogeneous equation, linear differential equation, exact differential equation, integrating factor, change of variables. There are some methods to solve these equations. They are variable separable, differential equations reducible to variable separable, homogeneous equation, differential equations reducible to homogeneous forms, linear differential equation, differential equations reducible to linear form, exact differential equation, integrating factor, change of variables. These are the various methods to solve differential equations in the standard forms. Let us discuss the variable separable method. This method involves in separation of variables in an equation as the first step. Separation of variables. If in an equation it is possible to get all the functions of x and dx to one side and all the functions of y and dy to other, the variables are said to be separable. For example, consider the equation x dy is equals to y dx. Let us write x and dx at one side of the equation and y and dy on the other side. We get 1 by y of dy equals to 1 by x of dx. In this way, we rewrite the given equation to variable separable form. Before going to solve a differential equation, let us know the working rule. Working rule to solve an equation in which variables are separable. We have 3 steps here. First, we rewrite the given equation by separating the variables and then integrating the rewritten equation to get the final answer. These are the steps to follow to solve an equation in which variables are separable. Note that to the final solution, c must be added. Then only it is considered as the general solution. And c can be chosen in any suitable form to obtain the final solution. Generally, we take c in some solutions as log c, tan inverse c, sin c, e to the power c, half into c, minus 1 by 3 into c, etc. Now let's understand the solving the differential equation of first order and first degree with some example. The first one is solve 1 minus x of dy plus 1 minus y of dx equals to 0. Given differential equation is 1 minus x of dy plus 1 minus y of dx equals to 0. For separating variables, we rewrite the given equation as 1 minus y of dx equals to minus 1 minus x of dy, implies dy by 1 minus y equals to dx by 1 minus x, implies dy by 1 minus y plus dx by 1 minus x equals to 0. Now integrating the equation, we get integral dy by 1 minus y plus integral dx by 1 minus x equals to 0, implies log of 1 minus y plus log of 1 minus x equals to log c, implies log of 1 minus y of 1 minus x equals to log c. Since log m plus log n equals to log mn, cancelling log on both sides, and we have 1 minus y of 1 minus x equals to c, which is required solution. The second example is solve dy by dx equals to x of 2 log x plus 1 by sin y plus y cos y. Separating the variables, we get sin y plus y cos y of dy equals to x of 2 log x plus 1 of dx. Now integrating, integral sin y plus y cos y of dy equals to integral x of 2 log x plus 1 of dx, implies integral sin y dy plus integral y cos y dy equals to integral x of 2 log x of dx plus integral x dx, implies minus cos y plus y sin y plus cos y equals to 2 of 1 by 2 of x square log x minus 1 by 4 of x square plus x square by 2 plus c. Here minus cos y and cos y get cancelled. Then we have y sin y equals to x square log x minus x square by 2 plus x square by 2 plus c. Minus x square by 2 and x square by 2 gets cancelled. Finally, we have y sin y equals to x square log x plus c, which is required solution. The third example, we have solve 3 e to the power x tan y dx plus 1 minus e to the power x secant square y dy equals to 0. Rewriting the given equation, 3 e to the power x by 1 minus e to the power x of dx plus secant square y by tan y dy equals to 0. Integrating, integral 3 of e to the power x by 1 minus e to the power x of dx plus integral secant square y tan y dy equals to c. Now put 1 minus e to the power x equals to t. Differentiating this, we get minus e to the power x dx equals to dt, implies e to the power x dx equals to minus dt. Substitute the value in the above equation, we get integral 3 of minus dt by t plus integral secant square y by tan y dy equals to c. Writing 3 outside of integral, we have minus 3 integral 1 by t dt plus integral secant square y by tan y dy equals to c. From this we have minus 3 log t plus log of tan y equals to log c. By the formula, integral f dash of x by f of x of dx equals to log of f of x plus c. Replacing t equals to 1 minus e to the power x, we have minus 3 log of 1 minus e to the power x plus log of tan y equals to log c. Implies log of 1 minus e to the power x whole to the power minus 3 plus log of tan y equals to log c. Implies log of 1 minus e to the power x of minus 3 of tan y equals to log c. Implies log of tan y by 1 minus e to the power x whole cube equals to log c. We cancel the log on both sides and then we have tan y by 1 minus e to the power x whole cube equals to c. That equals to tan y equals to c of 1 minus e to the power x whole cube, which is required solution.